All right, in this question, we're kind of jumping back to last term, and we're thinking about ionically versus covalently bonded molecules. Now, this is important because we're getting into a section here on solubility. Does something dissolve? And so the first part of that is deciding if something will break up into ions, because it's important to know if we're dealing with ions or if it just will stay as a covalently bonded molecule. And then we can think about intermolecular forces. Is it going to mix? Is it not going to mix? And we can think about with ionics, the state of the charge, how strong is the charge? And so we can start making some educated guesses from there and then look more into solubility. So here, what are we looking for? We're mostly looking for is an ionic or covalent. So if we go down this list here, we got methanol, right, which is carbon-based, covalently bonded. So they're all non-metals. It's an alcohol, so it means it would dissolve well, but we're not looking at that. We're just looking at a covalently bonded molecule. So what species are in there? And notice up here, it says, we know that water will be present, so you can begin with water. So we can say H2O, and we can say CH3 and methanol. If we look at the next one, same thing. We got carbon-based glucose. This is sugar. We've seen sugar go into water, and we see it stays as a molecule. We don't break those bonds. So again, we're going to see H2O, and we're going to see our sugar. For this last one, we see it's got a metal, iron, and it even tells us iron 2, and that we see there's 2 iodides. Iodide is -1, it's in that group 17. And so we have an iron bonded with 2 iodide ions. Now we're not looking for molarity or anything here, so we're going to say Fe, but we are looking for the correct charges. So we got a 2+, and we got an iodine, which is a -. Okay, so those are the species. What does it break up? Only this iron iodide breaks up into ions in water. There we go.